So when we look at proportions and ratios and percentages, are we talking about a multiply divide relationship or an add subtract relationship? Well, we've talked about this quite a bit. It is definitely a multiply divide relationship. Okay, so we are talking about multiplication and division. We're talking about factors, we're talking about multiplying and dividing factors. We're definitely not talking about add and subtracting pieces. Okay, in fact, sometimes when we have adding, subtracting pieces, it really does mess up our math. It makes it difficult to deal with. We can, but it's definitely not proportional anymore when we start talking about add and subtract. So when we have a proportional equation like this is a equivalent fraction or a proportional equation. There are some multiplying and dividing pieces in here. Okay, so we have our times divide factors. For example, we can go from here to here. Okay, we can times by, well, if I want to find my times factor, I can divide, and I end up with 5 over 3. Okay, so I can times by 5 over 3. Well, that means then that I can times going down here in the same direction, I can times by 5 over 3 as well. If I multiply in one way, I can go in the opposite direction and divide by that factor. Okay, so I could divide by that factor. I could divide by 5 over 3, or I can times by a different factor, 12 divided by 20, and it's the same direction as the divide 5 over 3. I can times by 0.6, and that's all the same. Okay, these are all times divide factors. The relationship between the 5 over 3 and the 0.6 is a reciprocal relationship. We actually can flip that fraction upside down and get 0.6. So those are times divide, add, subtract relationships. There's also, no add, subtract relationships, just times and divide. There's a horizontal times divide relationship, then there's also the vertical one. And this one is how we usually find our unit rates. So 15 compared to 12, okay, we can show this as 5 parts to 4 parts. Okay, so this is times by 1.25. And then we have the exact same relationship in that we can divide by going in the other direction. Okay, we can divide by 1.25, or we can multiply going in the same direction. Just choose a different color here. In this case, I can multiply by 20 divided by 25, which is 0.8. So dividing by 1.25 is the same as multiplying by 0.8. Okay, so there's all these times divide relationships that are involved in here. So notice that what we have here, we started with 15 over 12, and oops, this is a typo here. This should be, if we change this to 15 over 25, okay, oops, sorry, I change this to 15 over 25. Is 15 over 25 the same as 12 over 20? Okay, does this proportion still work? So test it out. Okay, so how are some ways we can check it? Well, we can see if there's times divide factors are the same. Okay, or we can just divide. So 15 over 25 gives me 0.6. 12 over 20 gives me 0.6. They're equivalent fractions. We could test this by finding our times and divide factors. 12 divided by 15 gives me, what would that be? That's going to be 0.8. Okay, 20 divided by 25 is also a times by 0.8. So this relationship, even though we switch some numbers around, this still works. This is the one thing I want you guys to start understanding about the proportional relationship, is that we can rotate this. So if I take these numbers, same numbers, and I rotate them around clockwise. So I'm just going to put my equation in here. So I'm going to rotate the 12 into the top position. Okay, the 15 is going to rotate over here to this position, the 25 is going to rotate down to this position here, and the 20 is going to rotate in the clockwise direction into where 12 was. And if we write this relationship, we're just basically turning it on its side. Okay, this proportion still works. 12 to 20 is equal to 15 to 25. Okay, we can flip it upside down. Okay, we can flip this ratio upside down, and when we flip the ratio upside down, that proportion still works. Okay, 20 divided by 12 is the same as 25 divided by 15. This proportion works in all sorts of directions. There is this diagonal relationship as well. We can actually spin it across a diagonal line, and we get 15 and 20, and this relationship again holds true. Okay, 15 divided by 12 is the same as 25 divided by 20. So there's all sorts of this symmetry that exists within this proportional relationship. Now you don't need to know all of them, but it is useful to understand that there's this vertical relationship, there's this horizontal, and there's also this diagonal relationship. And some people like to say that you can cross multiply because of that. Well, that's actually true. So, does this work? Yes. Okay, this relationship still works. Okay, and the reason why is because this ratio relationship has a lot of symmetry to it. There is a lot of symmetry embedded in the proportional equation. Okay, and if you understand at least the horizontal and the vertical relationship, that is going to be very useful because we have different ways we can then look at it. But again, there is more symmetry. In fact, there's this diagonal symmetry that also exists that we can take advantage of. So definitely, yes, we can just rotate these terms around, and we can generate an equivalent proportion even when we do that.